Today we're going to be looking at organizing data into matrices. A matrix basically is a rectangular arrangement of numbers in rows and columns inside brackets. Matrices can be described by its dimensions or the number of rows and columns. So that's something you need to keep in mind. You want to know the number of rows and columns in the matrix. A matrix with a certain number of rows and a certain number of columns is called an M by N matrix. So you always go rows first and then columns. Okay, let's take a look at an example. We're going to state the dimensions of this matrix, and then we're going to identify the position of the circled element. How many rows does this have? It has 2 rows, and how many columns? So we say it's a 2 by 3 matrix. The circled element is in which row? First row, third column. And that's the way you state it. It's first row, third column. It's kind of like where you're seated in the classroom. Okay, so let's take a look at some examples. We're first just going to kind of get a handle on what are we talking about a matrix, identifying what is this size or how do you state this matrix, and what is this matrix? It's a 2 by 4. I have 2 rows and 4 columns. Okay, can you state the position of the circled number? Okay, it is row 2, column 2. Okay, what are the dimensions of number 2, this matrix? Okay, it's a 3 by 3. And where is the circled number located? Row 3, column 2. All right, in this one, a 1 by 5, and it's located on row 1, column 2. Okay, what are these are actually used in real life is if you are wanting to compare data, let's say for instance, in this example, somebody owns a bunch of apartments or homes or condominiums, it says, and they have what is a 1-bedroom, 2-bedroom, and 3-bedroom costing, and then they have several different complexes of condos. Okay, and maybe even in the same town. And you might, as a business person, want to compare, like, how well is this condo doing for me? How well is this subdivision doing? You know, where am I making the most money? And you know, if I own a bunch of Casey's stores, which I think the Casey's store owners do, they own several, more than one, in an area, you might compare and say, okay, how's this Casey's store in Shalbina doing as far as making me a profit compared to one maybe in Hannibal? And doing so, that's how they make decisions as to whether or not they keep stores open or if they decide maybe I need to close one. Okay, oftentimes in one store they make enough overhead, you know, they make enough profit on it that it covers maybe another store that isn't making quite as much profit. Kind of the same thing with your C&R markets in our community. Okay, we're going to write a matrix to organize the selling price of the condo. Okay, what do you think we're going to have? What is going to be the dimensions of it? A 3 by 3. Okay, so we might put these are our expenses, and then the dimensions are going to be, let me get a smaller pen here, 349,000, 449,000, and 499,000. And then on the second row, we're going to have 329,900, and then 389,900, and 439,900. Now you may be saying, okay, why am I writing this out? Well, later on you might have 2 sets of data that you're going to do some kind of mathematical calculations with. But right now we're just talking about how is a matrix organized. So that would be how I'd write that data in a matrix. What are the dimensions of this matrix? 3 by 3. And which condo is the most expensive? Three-bedroom at where? Keene Mills. So you can say Keene Mills 3-bedroom. Or I could say row 3, column 3. What about the least expensive? Where? The least expensive. 349,000 cents, and the smallest, it would be 2-1. Or we can say the Salmon Brook. And it is the 1-bedroom. Or I could say row 2, column 1. Okay, now once we have our data organized, then you can do some calculations on your matrices. If you have 2 matrices, but they must have the same dimensions. Okay, then you can either add that data together, or you might be subtracting them. And then we're also going to look at multiplication, and that's called a scalar multiplication. So here I have 2 matrices. Are they the same dimensions? Yes, this is a 2 by 3. This is a 2 by 3. Then they ask us to find A plus B. So what you do for each spot, okay, or for wherever each digit is, each element, then you're going to find their total. So A plus B is, then I have this matrix and that matrix, and I combine them. So I'm going to take 2 plus 0 to give me 2, a negative 1 plus 2 to give me 1, and an 8 plus a negative 4 gives me 4. Then I do the second row. Second row, column 1, a negative 3 and a 5 gives you a positive 2. A 4 and a negative 6 gives you a negative 2, and a 0 and a 3 gives you a 3. And so that's called your solution. So that's all you did, was you just added, but make sure that you take the same row and column by each other. Okay, then when you multiply, it says if C is this matrix, then we're going to find negative 3C. So we're actually taking a negative 3 times each element or quantity in this matrix. So in your mind, you're thinking negative 3 times 2, negative 3 times negative 10, negative 3 times negative 3, and negative 3 times 1. And you write down the results in a 2 by 2 matrix. So negative 3 times 2 is a negative 6. Negative 3 times negative 10 is a positive 10, and negative 3 times a negative 3 is a 9, and negative 3 times a 1 is a negative 3. That's it. Now, the only way that you cannot work them is if they don't have the same dimension. For instance, if I have a 1 by 4 being subtracted from a 2 by 2, you can't do that. Okay, it will not work. Okay, let's see if we can perform the indicated operations on these matrices. It says, if the matrix does not exist, write impossible. Can we add these? Okay, this is a 2 by 2, this is a 2 by 2, so we can. And what are they going to be equal to? Well, a 3 and a negative 1 is negative 5 and 4, 2 and 7, and 0 and 3. Okay, so that's your solution. Can I subtract those two? Nope, so this one would be impossible. Can I do those? Can I add those two together? Okay, this one, 2 and 1, I'm adding, is 3. Negative 1 and 2, 5 and negative 3 is 2. Looks like I need to extend this a little bit. And what's 0 and 8? And negative 3 and 1? 4 and 0. So it is a 3 by 2. Okay, can I combine those two? Now, what operation am I doing? Now, here's where it gets a little tricky. Because I have to think 9 minus 3, which is negative 1 minus negative 2 is a positive 1 because you do mark, mark. 2 minus 0 is 2. 0 minus a negative 4. It's a 4. Mark, it'll be positive 4. 0 minus 3. Negative 3, or excuse me, wrong one. 4 minus 3 is 1. And then 3 minus 5, negative 2. And that's your solution. Okay, now can I do this? Can I do a scalar? Yes, I can. 2 times 2 is 4. 2 times 4 is 2 times 0. 2 times negative 1. Okay, what about this one? And the last row? Okay, what about this one? Negative 2. Okay. Don't forget to put your brackets around them too, please. And the last one. You got it. Now, you might say, were we ever really going to use this? We're not going to take this method, but this method of where you set up matrices, and it's called like an augmented matrix, can be used to solve a system. We're not going to take the time to go into that, but I will give you some information regarding that.